Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. Now, if you have younger brothers and sisters who would want to become engineering students and hopefully engineers in the future, then you may share this video to them as well as your relatives and loved ones. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So in this video, I call it Vitamath 5 because this problem would be your vitamins in mathematics in your preparation as engineering students. We're going to show that the area of a I'm going to show that the area of a triangle is given by ABC over 4R, where A, B, and C are the sides and R is the radius of the circumscribing circle. And after that, we have to determine the area of the triangle if the product between any two sides is 1,300 square meters and the angle included is 61 degrees. So I'll use the principles already uploaded in this playlist Beta Mathematics or Beta Math, so that that principle in particular could be retained and applied by you anytime you are confronted with problems where the principle is applicable. So here is the demonstration or the process of showing that the area of a triangle is ABC over 4R. First, we name the corners, the points A, B, and C of the triangle. Then the sides correspondingly opposite to vertex A is side A, small a. This is small b, and that is small c. Then we drop the line perpendicular to AC, and that's the height of the triangle, so that this height and the base, which is horizontal, will be perpendicular to each other, so that the basic area of a triangle is 1/2 base times height. Then this height from this right triangle here is C sine angle A, either C sine angle A, hypotenuse sine of angle A, that's the opposite, or hypotenuse A in this right triangle here, sine of angle C. So that is C sine angle A or A sine angle C. If we drop a line through C here, this altitude here, which is perpendicular to C, then that would also be B sine angle A or A sine angle B. So that we can also show that that height is B sine angle A or A sine angle B, so that we can present later or derive later the law of sines or the sine law. So from here, if we replace H by C sine angle A, then we'll have area of triangle 1/2 B times C sine angle A. So therefore, area of triangle is 1/2 BC sine angle A. If you're going to read this formula, it is simply 1/2 the product of any adjacent sides, B and C for example, times sine of the angle included or the angle between these two sides here. So therefore, based on that pattern, the area of triangle is also 1/2 AB. A and B are adjacent to each other times sine of angle C. It is also equal to 1/2 A times C, these adjacent sides here, times sine of the angle between them, which is B. So if we replace H by A sine angle C, so area is 1/2 of B times A sine angle C. So that's why area of triangle is also 1/2 AB sine angle C. So we conclude by the pattern for the area that area of triangle is also 1/2 AC sine of angle B. So area of triangle is 1/2 AC sine of angle B. So in short, the area of any triangle is equal to 1/2 the product of any two adjacent sides times sine of the angle between those sides. So the stated in words, the area of a triangle is 1/2 the product of any two sides and the sine of the angle between these sides. So I hope you can easily recall that it is just 1/2 the product of any two sides of the triangle times sine of the angle between those sides. So that's it. Then equating C sine angle A and A sine angle C, then we can form this equal ratio of A sine angle A equals C sine angle C, which can be extended as B over sine angle B by looking at the pattern. So that ratio, the ratio of any side to the sine of the angle opposite it, is constant. So in other words, side A over sine of angle A equals side C over sine angle C. Then by deductive reasoning later, it is also side B over sine of angle B. So now that we have formed that area of triangle is 1/2 the product of any two sides and the sine of the angle between these sides. So let's locate the center of the circle that at O. Then remember that any angle, interior angle, is a peripheral or inscribed angle. And by principle, that angle is equal to 1/2 the measure of the angle occupied by its subtended arc. So for angle A, for example, arc BC will occupy an angle known as central angle, which is double this angle A here. Because remember, the principle, the inscribed angle is 1/2 the measure of the angle occupied by its subtended arc. So therefore, this should be 2 times angle A. So this is an isosceles triangle. The measure of this angle should be 2 times angle A because the radius of the circumscribing circle is R. This is also R. Therefore, triangle BOC is an isosceles triangle. And I said, by principle, from the preceding problem here, so you have to watch the videos in series so that the principles are arranged or organized in such a manner that you can recall the principles previously discussed in the videos. And let's apply it here. So this is 2 times angle A. And because this is an isosceles triangle, if we drop a line perpendicular to the opposite side, this angle to angle A will be bisected. And therefore, this angle here is angle A only, half of 2 angle A, and that's 90 degrees perpendicular. The opposite side is also bisected. Therefore, the length from this point B to the foot of this perpendicular is A over 2. So this is angle A, and this is side A over 2. That's side A over 2. Then in this right triangle, sine of angle A is equal to A over 2 divided by hypotenuse, which is the radius of the circumscribing circle. So area of triangle is 1/2 BC sine angle A, and sine angle A is defined here in this right triangle as A over 2 over big R. So area of triangle is 1/2 of BC times quantity A over 2 over big R. Finally, we can now show that area of triangle is really ABC over 4R. So that's the first part. The second part is this. We have to determine the area of the triangle if the product between any two sides is 1,300 square meters and the angle included is 61 degrees. Since we derived formula earlier that area of triangle is 1/2 product of any two sides times sine of the angle between those sides. So if we use this formula and the product BC is any two sides is 1300 and one angle is 61 degrees, therefore the area of triangle is 1/2 times 1300 times sine of 61 degrees. So your area of triangle is 1/2 BC sine of angle A. So the product BC is any two sides is 1300 and the angle included is 61 degrees. So 1/2 of 1300 sine of 61 degrees. Therefore the area of the triangle, if this is the condition, is equal to 568.5 square meters. So that's it for this problem, and I'll extend this because this the ratio of any side of the triangle to the sine opposite it is constant, and it is also C over sine angle C. It is also B over sine angle B. So A over sine angle A equals C over sine angle B equals B over sine angle B. This is the law of sines, and this ratio is a constant, and let us show that it is constant because here sine angle A is A over 2 over R. So sine angle A is A over 2 over R. That means sine angle A is A over 2R. So therefore A divided by sine angle A, which is equal to B over sine angle B, which is equal to C over sine angle C, is constant really, and it is equal to the diameter of the circumscribing circle. 2R is the diameter. So A over sine angle A is equal to 2R. So by sine law, remember A over sine angle A equals B over sine angle B equals C over sine angle C equals 2R. And take note, 2R is the diameter of the circumscribing circle of a triangle. So stated in words, the ratio between any side of a triangle and the sine of the angle opposite it, or the sine of the opposite angle, is the diameter of the circumscribing circle. And I hope that you can retain that. You can put that in your mind, and I hope it will not be forgotten, because that principle is very important in deriving other geometric formulas, other geometric relations, and formulas in plane trigonometry. So that's all.